Hello everyone. In this video, we will introduce some elements about hydraulic components, such as hydraulic pipes, valves, pumps, and hydraulic jacks. There are four learning objectives. There are causality in hydraulic pipes, submodels of pipe, line submodel selection, and other hydraulic elements such as pumps, valves, and so on. We can find that there are three groups of lines. Here we need to emphasize that direct connection isn't a submodel of pipeline. What are these three groups? They are lumped parameters models, distributed parameters models, and CFD1D models. The first two models provide FDF option to us, and if we need to, we can activate this option to consider frictional resistance of the pipe. And the CFD1D model are not considering the frictional resistance of the pipe. For lumped parameters model, we can consider that the model consists of one chamber and one resistance element. For distributed parameters model, we can also consider that they are consisting of several series pipes. And the CFD1D models is using the method of finite element analysis, so they're using the internal solver to deal with continuity, motion, and FDF equations. Depending on the internal structure of the line and the boundary causalities, the hydraulic lines can have three different causalities. The reason for this is the input and output characteristics of external variables of a submodel. If we connect a pipe to a component, the component submodel normally does one of the following two things at the connection port. It calculates the flow rate at output from the pressure at input, or it calculates the pressure at output from the flow rate at input. In each case, the pipe submodel must provide the correct variable for the component submodel. The hydraulic lines can work as a wild card, allowing all kinds of the connection in the sketch. SimCenter MSim will introduce automatically lines if the causality between two components don't match together. Depending on the boundary causalities and the objective of the simulation, we have different available submodels, and they can be sorted to two main categories and five subcategories, which are lumped elementary, lumped basic, lumped distributive, lumped distributive with inertia, and CFD1D. Generally, different submodels have different solving equations, and the complexity of solution increases from top to bottom. In the previous slides, we introduced the submodels and causalities of pipelines. Now we will show you how to select a suitable submodel for a pipeline. Let's consider a pressure source connected to an orifice, as shown in the following sketch. Causality is okay, and a direct connection can be used between the pressure source and the orifice. If you want to add a line model, you can move to submodel mode and select one submodel by double-clicking the connection line between the pressure source and the orifice. As explained in the previous slides, several line submodels are available in SimCenter MSim, but depending on the boundary causalities in your system, you will have access only to some of them compatible with your actual configuration. In this model, there are 5 options we can choose. We can build models as shown below, and set parameters referred to this slide. Here we build 7 pipeline systems in one model, so we can compare the results conveniently. When we completed the model, we can run the simulation. Let's look at the simulation results. This picture is the pressure variable of the inlet of orifice. We can find that curves are different. White curves are different because capacitive or resistive or inertia can be considered by different submodels. With different curves at previous slide, are you confused? There are 15 submodels. How to select a compatible submodel for pipe? First, we should know what factors have influence on the result. There are some analysis values, parameters of lines, and fluid properties. AR means the aspect ratio. It is defined in terms of the length L and hydraulic diameter dH. dN means dissipation number. We can calculate it by the equation shown in the middle. T wave means wave travel time. That is the time taken for a pressure wave to travel down the pipe. It can be calculated from the equation shown at bottom. Lumped lines are very well suited for systems such as large actuation systems and hydraulic jacks. The CFD1D line models can be used to represent longer lines in which it is necessary to represent wave propagation accurately. So we can choose one category based on pipeline's application, and we can also give the number of nodes based equation in distributed lines. When the AR coefficient is bigger than 12, we can decide whether to use a frequency-dependent friction according to the value of dn. MSIM is a user-friendly software. There is a line selection assistant tool. It can help us to pick the right submodel for our line components. In the parameter interface, left-click the line, then click the icon as shown as number 2. Finally, we can get an interface like right side of this slide. We can get the recommended submodel by the line selection assistant tool according to the necessary input parameters. There are also some other important components such as control valves, pumps, and jacks. Many control valves exist in the hydraulic libraries. They vary depending on the number of positions and the number of ports. The flow characteristic of a valve way or flow path is defined by a QDP pair at maximum opening. The flow paths are defined as function of the valve displacement. For each way, the area is defined by Sx equals to Smax multiplied Fx. Different pumps are found in the SimCenter MSIM hydraulic libraries, such as volumetric, centrifugal, gear pump, etc. Pump components are transformer elements. A conversion is made from mechanical energy to hydraulic energy. Hydraulic jacks are also transformer elements. They can transfer hydraulic energy into mechanical energy, and vice versa. Let's make a summary. We introduced the causality in hydraulic lines, 15 submodels for pipes, pipe submodels selection method, and other hydraulic elements, such as control valves and pumps. That's all for introduction about hydraulic pipes, valves, and other components. Thank you.